background noises down. Okay,
Silent.
girls, I'm recording, so. All right, inverse derivative rules. If you know the rules, it's plugging in. So you should, it's like quadratic formula. If you know A, B, and C, you plug them into the formula, you get the answer. If you don't know the formula, you're not gonna get the answer. So we have to learn these. That's why we are quizzing you on Monday, because you need to learn them before you take the test. All right, so our first derivative rule for inverse trig is arc sine. So the derivative of arc sine is u prime. Sorry. There we go. Right there. All right, so it's u prime, so this is u. So you take the derivative of that and then the square root of 1 minus u squared. All right, the derivative of arc cosine is the exact same thing, but a negative. So it's u prime over the square root of 1 minus u squared. Arc tangent and arc cotangent are both u prime over u squared minus 1, or sorry, u squared plus 1. But again, arc cotangent is negative. So again, the ones that start with C are negative. Arc secant and arc cosecant, those are the more complex formulas. I think of them as the more complex trig function, so that's how I kind of remember it. And it's going to be u prime absolute value of u times the square root of u squared minus 1. I also remember that the more complicated one, the absolute value of u and the u squared match up, kind of, they're next to each other, where in arc cosine and arc sine, it's 1 minus u squared. So that's how I remember the order, but it's just however your brain. Luckily, our questions that we're doing are on a different page, so keep those formulas handy so that you can look at them because you don't know them yet. So we are finding the derivative of each of these examples, and it should go pretty fast. So first thing I like to do is write the formula. So the derivative of arc sine is u prime over the square root of 1 minus u squared. Then I'm going to go off to the side and I'm going to identify what is u, the square root of x. So what is u squared, x, and what is u prime? So what is the derivative of square root of x? Good. A lot of you are jumping right to that. Some of us aren't there yet, and that's okay. You bring the 1/2 down, subtract 1, but then you can move it down. And now you just plug into the formula. So my answer is going to be u prime, which is 1 over 2 square root of x, all over the square root of 1 minus x. It's squared 1 minus x. But we need to get rid of that little fraction. Now, a lot of you want to just take this and bring it down to the bottom. This problem, you can do that because there's no other term on top. So you can just rewrite that as 1 over 2 root x and then 1 minus x. And that's it. Yes.
What's u squared for 1 minus u squared, the square root of x?
Yes, u squared, right here. U is square root of x, so u squared would be x. Yep.
Is it like the derivative rule the same for arc cosine?
Arc cosine is exactly the same except negative.
Oh,
There's a negative in front of there. All right, questions on that one? All right, tangent. So again, I'm going to write what is my derivative of tangent is u prime over, did they write it as 1 plus or u squared?
u squared plus u squared.
U squared plus 1. It doesn't matter because you're adding. So off to the side, my u is 3x, which means u squared is 9x squared. You have to square both terms. And then u prime is looking at the derivative of u, which is just 3. And then we plug in. So y prime is 3/9x² plus 1. And no, you cannot reduce that 3 and the 9 because of the plus 1. That's just your answer. So do you see how these are pretty easy if you know the formulas? Okay, arcsecant. So formula for arcsecant, that's the more complicated one. So it's u prime, absolute value of u, u² minus 1. U is e to the 2x, which means u² is e to the 2x², which is e to the 4x. Power to power, you multiply the exponents. And then u prime, we have to remember the derivative of e to the u is e to the u times u prime. So e to the 2x times 2. Then we plug in. So y prime equals 2 e to the 2x over absolute value of e to the 2x, square root of e to the 4x minus 1. Okay, so now we can cancel out the e to the 2x, but that's because these absolute, no, it's because the absolute value bars don't matter for e to the 2x. Why do they not matter?
It's a positive number.
It's always going to be positive. So this is really the same thing as just dropping dropping those absolute value bars. Now, if that was an x², would the absolute value bars matter?
Yes.
Yes. So you wouldn't be able to drop the absolute value bars if it was an x². So if you had an x² here and an x² inside the absolute value, you wouldn't be able to cancel them. But because, or I said x² you would be able to because that's always positive too.
Why is it always
X or x cubed, then it wouldn't.
Why is it always positive?
Because e to any power is always positive. It's an exponential function that's always above the x-axis. So this final answer we can write as 2 over the square root of e to the 4x minus 1. Again, let me start over. If I had x and then the absolute value of x like that, I wouldn't be able to cancel those because you can't get rid of the absolute value bars. That's what I meant to say. All right. Okay, this one's a little bit different because we have a function divided by a function. So the big picture is quotient rule. So when I find the derivative of this expression, I'm going to be doing quotient rule. So low, d high. I'm going to write this as arc sine 5x prime, like the derivative of that. So low d high minus high d low all over low low. So within that quotient rule, now we have to find the derivative. We have to find the derivative of arc sine. So the derivative of arc sine 5x, so u is 5x. U² would be 25x². U prime would be 5. So the derivative is u prime over the square root of 1 minus u². And that expression right here is going to go in that place. Okay, so are you okay with me, since it's x times this, can I write it as 5x on top? Or never mind, I'll leave it, I'll leave it.
Just, you like this?
No. Think about how far you've come from the first day of calculus with getting rid of little fractions within big fractions. If I said you could just leave it, you would not be growing and getting better. All right, so what I was saying is this x can really go up there with the x to the 5. But this is what I was talking about. Some of you are still just taking this square root and moving it to the bottom. You cannot do that because of this minus sign. So we have to multiply the top and bottom by the common denominator. Yep.
And you're not finding like, you're not doing the same thing on that term because it's not the derivative.
So, yes, this, we're not taking the derivative of arc sine. That's why we don't have that formula there. But we have to take this and distribute to each term. So the derivative is 5x. Those cancel. Minus, I'm gonna write this first because, just because. I mean, I hope that some of you are starting to be able to do that in your head. A little bit. Maybe
Do what? That?
get rid of the little fractions.
Oh,
And that's our final answer. I mean, it wasn't that bad, right?
not really.
All right, questions on that one? Got 30 minutes? Oh geez, we might be. All right, here. Derivative of arc cotangent is negative u prime over u squared plus 1. So u is x over 2. I personally changed that to be 1/2 x. Because sometimes when I see x over 2, I want to think quotient rule. But if I rewrite it as 1/2 x, I know it's a lot easier than doing quotient rule. What would u squared be? 1/4 x squared, and then u prime is just 1/2. So my derivative is 1/2 over 1/4 x squared plus 1. And I have to get rid of those little fractions. Yep.
What is the negative?
Oh, thank you. Forgot the negative. Some of us learned the hard way. If you put a negative in front, that is making the entire thing negative. If you put it on top, it's only the top negative. What should I multiply by to get rid of that little fraction?
Ooh.
If I multiply by 2, it wouldn't get rid of the 1/4. So we want to multiply by 4.
I don't know you had to get rid of that.
So 1/2 of 4 is 2, and then don't forget you have to distribute that 4. So you would get x squared plus 4 on the bottom.
It is negative.
Yes, oh my goodness. Why do I keep forgetting my negative? Thank you. All right. We need to picture, yes. I'll look at it out. All right, the last problem is a function inside of a function.
I know lower this.
So it's chain rule. What's the derivative of tangent? I keep the inside the same. but then I have to chain on the derivative of the inside. So I have to use a formula for that. So because it's just X, like if I'm going to do this one here, oh, thought I changed it to red. If I'm doing this, U is X, which means U squared is X squared, and U prime is just 1. So my derivative is secant squared arc cosine X. And then the derivative of arc cosine is negative U prime over square root 1 minus U squared. And I'm fine with you leaving it like that or bringing the negative in front. Maybe bringing the negative in front. And then writing that on the bottom. I don't think that very many students use this idea anymore, but realize that tangent and cotangent are reciprocal functions. I want to move up. So if I change from cotangent to tangent, I would just take the reciprocal of 1/2 and make it 2. That's just if you didn't want to, like, if you didn't remember one formula, but you remembered the other, but those two are very similar formulas, so, but that's just one strategy that you could use. But like I said, I don't think very many. Yes, that's it for notes, right? It's not an example.
Wait,